Hi everyone, welcome back to Operational Technology Security. Today we'll revisit network security and we'll discuss everything we need to understand network security in the context of operational technology. In a nutshell, network security is about the CIA triad, confidentiality, integrity, and availability, focusing on computer networks and data using both software and hardware technologies. As you can see on the slide, it can be split into 5 different broad categories. First, segmentation in zones. We already discussed several times in the past the concept of an enterprise network and the control network. So you can think of them as different zones with different security characteristics. But you can further split in the enterprise zone into what interfaces with the external world, what's internal to the business, or you can split the control zone into what is in the supervisory area where the humans would stand with the HMIs, and what would be in the actual control, in the actual area where the sensor and actuators are. So segmenting into zones allow you to have different security levels for each zone. Again, the enterprise zone will be very different from the control zone, and also ensures that if you get infected, the infection will stay within the zone and won't propagate, hopefully won't propagate further. So that's segmentation in zones. Then network security also discusses encryption of communication and logical isolation. Encryption of communication is not very common within the network, but is essential when we have remote access to either the control or even the enterprise network. So when you connect through VPN, you have to ensure that the connection from your house to the organization is encrypted. And logical isolation is also important to ensure that the zones you have created are isolated in terms of networks. So they're different logical networks, and you cannot jump from one to the other without having to go through the gateway or a firewall that you will probably have in place. Speaking of firewalls, that will be the third broad area, control and filtering of traffic. Much of network security is connected to firewalls, but also proxies and other things. And this is where you create the isolation between networks. You don't allow traffic to flow from one network to another. For example, in the enterprise network, you have HTTP, you have FTP, you may have email, web servers. You don't want this traffic to go to your control network. At the same time, in your control network, you have Modbus, DNP3. You don't want this traffic to be going to the enterprise network. So firewalls can ensure that. And you have other ways, not just firewalls, but firewalls are primary elements of network security. Then discussion about extending security to the data link and application layers. So it's not only about TCP/IP. Coming from the IT side, we only think about routability IP and the transport layer, the TCP or UDP one. But the data link is very important. Ethernet, the way we connect to the devices, the PLCs, to the HMIs, we need to think security in the data link, but also go to the application. When you have your HMI, as we discussed before, you have your control software, your software that talks to the PLC. You also have to think about the security at that layer and have dedicated firewalls maybe for the application level, application proxy firewalls. And at the end, access control. In this context, you try to create a list of both who is accessing what, and also what computers are communicating to what computers at which IPs and which ports. So you're creating rules in a way about who has access to what, and the who again can be from human operators to computers to PLCs, firewalls, rules of access, whitelist, allow listing, deny listing, and you have to create the rules to again access and monitor and filter traffic between only trusted and well-defined elements. As a reminder, this is the OSI model. We saw it in one of the previous lectures. And again, physical to application layer. So in this, in today's module, we'll focus on the layers that are more relevant to operational technology. And if we think about it, they're the ones that are more closely related to towards the end of the stack, right? So on the physical layer, what we have to think, for example, wireless is introducing different security challenges compared to wired. And also, the physical layer is related to robustness of the network. So, for example, fiber may be a better choice to protect against harsh environments, electromagnetic interference, or other environmental conditions that may be harsh on regular cabling, like a regular Cat5 or Cat6 Ethernet cable. Data link may be the most relevant to operational technology security. We have the industrial Ethernet we discussed before. Both the connectors have to be of special type to withstand harsh conditions. But the Ethernet layer, because typically when you go to the control side, you don't have TCP/IP traffic, right? You may have nowadays some IP routability, but we still have many networks, control networks that are daisy chain or a star topology that you have proprietary protocols connected, nowadays through Ethernet though, through the industrial Ethernet. So this is one of the most important ones, and we'll see many attacks and defenses at the data link layer. Moving up to the IP, we do have now some more and more connections using IP routability, and we'll see how you can actually have a layer 3 security with IPsec or other protocols. Transport layer, TCP, relevant when we have remote connections. We may have also TCP traffic flowing through, again, due to the IT-OT integration. We see more and more of this TCP traffic, so we need to revisit the transport layer as well and see what kind of attacks and what kind of defenses can be implemented at that layer. But then we'll see it in conjunction with the rest, actually. So application and transport are tightly integrated in operation technology. So we'll see how we can look at the architecture more on from the application perspective, actually, that will integrate the transport layer. The traffic in the industrial network is well understood and well formed during the development of the industrial network. So we know which applications we have, right? We have Modbus, we have DNP3, we may have a web server for some reason, we have our data historians, our SCADA systems, and other things that don't change, they're static, they're not dynamic compared to the enterprise network that protocols can come and go. In the industrial side, the protocols stay fixed, and when they change, there is a proper change management process. So at the end, in a video, we'll see transport layer with all the way up to the application layer connected. So these are discussions of the different layers. So let's start diving into each one of them, starting with the data link layer.